First, we need to understand what roles and decoders are and where the logs are coming from. The log's journey starts from the device, which forwards it. If I show you, the agents send their logs on two ports, 1515 and 1514, while logs from agentless devices are received on port 514, which is the syslog port. The logs received on the port are stored in /var OSSEC log archive. In this archive, there is a log file named archive.log and a JSON file named archive.json. So first, when the log is received on the port, it gets stored in archive.log inside the archive. After that, it is matched with a decoder. If the log matches a decoder, it moves to archive.json. Now, after being converted into JSON format, if you open any alert, you will see this entire section. It comes under archive.json. Once the log passes through the decoder, it moves to var OSSEC logs alerts folder. Inside the alerts folder, we have alerts.log and alerts.json files. After matching with a decoder, the processed data from archive.json moves to alerts.log. Once in alerts.log, the log is matched against a rule. If it matches a rule, it is stored in alerts.json. Now, if I show you the alerts.json file, you will see the entire content displayed in the front end. When you navigate to the JSON tab, this is what you see. Here you can see the rule ID, the rule hit, the alert level is level 5, and the description, which is visible on the front end. So, for regex, we come to the browser and go to Regex 101, which is an online tool for writing regex. It will be very easy for you to write in this. So we will come here, paste our log, and in the top box we will write our regex. Now let me first explain the basics of regex. What are the basics of regex? This backslash and the small w means word. So reading will start from left to right. If we write a \w, it will read just the first word. And if we add a plus to it, it will continue reading multiple words until it encounters something other than a word. For example, it will read this, and then it will stop, because there is a space after it. Now, if I use \d, it will read decimal or integer numbers. If I just write d, it will match a single-digit character. But if I add a plus, it will keep reading until it encounters something else. So now you understand D means digits, W means words, and S means space. And if you use a dot followed by an asterisk, it will match everything. If you use dot asterisk, see, it reads everything. Here you can also see the result in the match section. See, I wrote D, and now in the match section it's picking up one digit at a time, then it stops, then it picks the next one, then stops. It is reading each digit separately and not grouping them together. If I now add a plus after it, see, match 1 now contains a whole number until it encounters something else. In match 2, it picks 3 digits together, and then it stops because of the decimal point. And if you use a dot asterisk by a question mark, the question mark defines where to stop. So, reading starts from the beginning, but you tell it that you are only interested in a specific part of the information. For example, suppose I only need an IP address from a log. What will I do? I will use dot asterisk, then add a question mark, and tell it to skip everything until it encounters a number. Now, if I use D after that, see what happens. The match now contains everything up to the first decimal point and then stops. However, if you use \d incorrectly, it might still include part of the unwanted data. To avoid this, you need to add a space after the question mark so that it correctly skips spaces and only reads what you need. Look, it skipped everything before the number, including spaces, and started from where it found the decimal. Now let's talk about parentheses. These brackets mean that you want to capture data, meaning whatever part of the regex is inside parentheses will be extracted and stored as a group or variable. For example, if you write something inside small brackets, that specific part of the regex will extract data from the log. And if you use capital letters instead, capital W will match everything except words. Capital D will match everything except numbers. Capital S will match everything except spaces. For example, if I use capital S, see? It has ignored all spaces but captured characters and numbers. So, these are just the basic regex concepts. Now, if I want to write a regex for this entire log, I will start by defining it. Here, I have this, followed by a space. Next, I need to hardcode something inside the regex so that the log matches the decoder correctly. So if I start by writing this at the beginning, but after that I see that this portion is not really useful for me, so I will use .*, followed by a question mark. I want to capture everything up until the word from. So I write from in the regex. After from, there is a space, so I will add space. Then comes the IP address. Now, how do I capture the IP address? I will use \D+ for the decimal numbers. Since an IP address consists of numbers separated by dots, I will write \D to capture numbers, dot to match the dot, \D for the next number, dot again, \D for the third number, dot again, \D for the last number. After the IP address, there is a space. Now, if I check the match section, I can see that my regex is capturing the entire required portion correctly. But what is really useful for us? The IP address. We need to extract it and save it into a variable. For that, I will enclose the IP address part of the regex inside small brackets. Now, see, it's still reading the entire log, but only the IP address is captured in group 1. Next, after the space, we have the word on, followed by a space. Then comes port, followed by another space, and then the port number. Since the port number is also important for us, I will enclose it in small brackets and use \D to capture it. Now, we have successfully captured both the IP address and the port number separately. That's it. This is our complete regex. Now that we have written this regex, let's move forward to decoders. Here, the decoders are located in the var, OSEC, etc. decoders folder under custom decoders. There are already some pre-written decoders inside. Now, you need to create a new .xml file for your custom decoder. We have created a file named test.xml. Since XML uses tags, we will start by opening the tag and closing it. Everything related to this decoder will be written inside this decoder tag. Every decoder has a name, so we will assign a name to this decoder. Let's call it Martin. A pre-match condition is used to help the decoder identify relevant logs from archived logs. This means that based on a specific keyword or pattern, the decoder will search for and extract matching logs from archived JSON file. For example, in our log, let's assume that the auth failed is a key identifier. We will copy and paste this as the pre-match condition. This ensures that any log in archive.json containing auth failed will be processed by this decoder. Then comes the regex. Next, we define the regex type. We specify PCRE2 because we have written PCRE2 type regex here, so we close the regex tag. Inside this regex tag, we will paste the regex we created earlier. At the end, we will create an order tag to store the extracted values from the regex into variables. Since we extracted two groups, the IP address and the port number, we will assign them to variables named value1 and value2. This is a simple basic decoder. Now that we have named this decoder Martin, we will call this decoder when writing a rule. So remember its name. I named it Martin now. Let's go back, close the decoder file, and return to var OSEC etc. Initially, we went to the decoders folder. Now we will go to the rules folder. We navigate to the rules folder where multiple files are already written. We create our own new XML file. Now inside this file, we define rules within a group tag and then close the group tag. Inside this group tag, we can write multiple rules. Every group also has a name, just like the decoder. So let's name this group. Now we need to create a rule. We define a rule tag and then close it. Every rule has an ID. You can assign any number as an ID. Keeping them in a sequence is better because it helps you remember the last used ID. If the same ID is repeated, it causes an error, or the rule is ignored. So if I check my available IDs, I'll pick one from them. I assign an ID. Every rule also has a level. Let's say we set this one to level 5, which is a low level. Now after this, we need to specify which decoder should trigger this rule. For this, we use the decoded as tag. Inside this tag, we write the decoder name, the one that triggers this rule. Now, after defining the decoder, if you want to add limitations or other conditions, you must first modify the decoder. That's more advanced. Since we are writing a basic rule, we simply say, if the Martin decoder is triggered, then this rule should execute. Next, we add a description tag. Inside this tag, we write what should appear in the front end when this decoder is triggered. For example, I write, Martin login failed from. If I write login failed, this will be displayed in the output. Now, if we want to display a dynamic value from a variable, we write it using a $sign and brackets. For example, if we want to show an IP address that caused a failure, we use $sign, and then in parenthesis variable name, we check the decoder and see that the first variable contains the IP address. We stored it as value 1, so we call it here. So, this becomes a simple rule. We save the file, exit, and restart the services. Now, we test whether this rule works in log test. We copy the log, restart, and go back. We can also check this in the dashboard. Now, if I paste the log into the log test backend, you can see. Phase 2, decoder. Phase 3, rule. It correctly extracts the IP address, which appears in the failure message. To confirm that the IP dynamically updates, I change the IP address in the log to 10.0.0.1 and copy-paste it into the log test. If I paste it, you can see it updates in real time. The value stored in value 1 dynamically changes in the rule description. A separate rule needs to be applied below. You have assigned an ID to the rule, keeping it in sequence, and set its level to critical. Now, regarding the frequency setting, you define it in such a way that, for example, if this rule is triggered 10 times within a time frame, let's say 30 seconds, then this rule will execute only once. The use case here is that if this rule is triggered 10 times within 30 seconds, it will execute once. Now, we close the rule, and to match it, we use the tag if_matched_SID, where we specify the ID on which this rule should be based. In this case, I have this match ID, and below, I will add a description. Multiple auth failures. After that, I save it, exit, and restart the service. Now, the service has restarted. Let's open our agent, go to that file, and paste the logs. Sorry, not here. Let's copy them first, and then paste them multiple times. I pasted it 3, 4, or 5 times together. Now, when I refresh, I check whether the Martin rule appears or not. Look, these logs are still showing as low because the frequency is below 10. Now I paste more logs to exceed that threshold. I have pasted more than 10 logs, so the 30-second time frame has been met. Now, critical should appear here. Let's see. Still not appearing. Wait a minute. Logs haven't been received yet. Now they are received. Now it shows multiple auth failures critical. Once 10 logs were hit, the critical rule was triggered once.
Get to know about us by visiting our website and follow us on YouTube, Instagram, and LinkedIn.